video is introducing improper integrals. It's page 19 of the Core Pure Year 2 notes and linked to chapter 3 in the textbook. Up to now you have evaluated what we call definite integrals, where we put in numbers. This part of the course looks at what we call improper integrals, and they are improper if they have limits that involve infinity, or if the function itself isn't defined between the two values on the limit. Now, what we do is we consider the area under the curve as it tends towards either the infinity or the value where the function is undefined. By considering the limit, this allows us to work out whether the integral converges to a value, because sometimes they do, or in fact has no value and doesn't exist, so it's said that it diverges. So let's have a look at the technique using question 1. Part A, I am being asked to find the integral between 1 and infinity for 1 over x root x dx. So my method for dealing with this is to change the infinity sign to another parameter. So in this case we are going to use t. So we're going to evaluate the limit from 1 to t, and we are finding the limit as t tends to, single arrow tends to infinity. And we've got x to the minus 3 over 2 dx. So the limit as t tends to infinity of the integral of x to the minus 3 over 2. I'm going to integrate, so I increase my power by 1 and I divide by new powers. So increasing my power by 1, I get minus a half. And I divide by my new powers, I'm dividing by minus a half, so that gives me minus 2. And that's being evaluated between 1 and t. So we now sub in our values as we always do when we are evaluating the integration. So we're working with the limit of t tending to infinity. I sub in the t, so I get minus 2t to the minus a half, and I take away the 1 subbed in, so that is minus 2. Putting in a 1 to minus a half, which is 1. So that's my values subbed in. Simplifying, t tends to infinity, and we have this becomes 2 and minus 2t to the minus a half. As a limit. Now let's consider what happens as t tends to infinity. So as t tends to infinity, 2t to the minus a half we can write as 2 over root t, can't we? And what's going to happen to that? That's going to tend to 0 as t tends to a half. So that means that this term will be 0, which means the value of the limit is going to be 2. So the integral from 1 to infinity of 1 over x root x dx equals 2. The integral has converged to a value. And it exists, so it is convergent. Okay, let's have a look at B. You will not be surprised, I think this one might be divergent, so you have a different sort of example. Let's have a think about what we're working with. We've got an integral between 1 for 1 over x dx. I am required to evaluate the limit. Now, which value is it that is causing the integral to be improper? There's no infinity. In this case, I've got two values, and it's the 0. When I sub 0 into 1 over x, it's going to give me an undefined solution. So it's the 0 that I change to the letter t. So we're going to let t tend to 0, and our integral will become t to 1 of 1 over x dx. So we want the limit of t tending to 0. We are going to do the integration. Mustn't forget to do the integration. So 1 over x integrates to log x. My values are 1 and t. And limit t tends to infinity. Evaluating, we have log of 1 minus log of t. Consider what happens as t tends to infinity. Log of t. Think about the log graph. Pop it on your graphics calculator if you need to. It's going to become minus infinity, isn't it? So log of t is going to tend to minus infinity. So we do not have an answer that allows the integral to exist. This hasn't gone to a number. It's still undefined. So the integral is divergent. Because we do not tend to a definite answer. Okay, one thing about notation that I just need to mention before we finish. As soon as you change the integral sign, rather than having the undefined number or the infinity in it, you must put this notation, limit of t tending to whatever the value is, in front of your integration. Otherwise, the maths becomes wrong. Because you've introduced this parameter here, you must have limit of t and the parameter tending to whatever value in front of your working. It has to go on every line. Okay, so there you go. You have one where we converge to a value and one where you haven't. And that's the end of the introduction video. Improper integrals